Hey, welcome everybody. So this is the first of the UCD's Institutes of Food and Health research bites for this academic year. Thank you for joining us. You're all very welcome. Our speaker today is Dr. Emma Feeney, who is a lecturer in the School of Agriculture and Food Science at UCD. And Emma has degrees from both Queen's University, Belfast, and in UCD, covering the areas of genetics and nutrition. She's had a number of postdoctoral posts in UCD and also in Penn State University in the US, where she has been working in areas including human nutrition and metabolism, functional food ingredients from dairy, and sensory evaluation. Emma's research interests also include food consumption patterns, genetic variation in taste, and the subsequent effect on food liking and choice. And today she's going to talk about some of her recent work in the area of cheese and cardiovascular disease. So over to you, Emma.
Thanks very much. You can hear some more people joining as well. So thanks a million, folks, for joining this afternoon. So just to give you a really quick overview of what I'm going to spend the next 20 minutes or so talking about. So I'm going to talk a little bit about reductionist approaches in food and health, and then I'll talk a little bit about food matrix effects. I'm going to move on into some evidence for cheese and cardiovascular disease risk. First of all, I'll talk about some recent meta-analyses in this area, and then I'll move on to some recent evidence from some of our own studies from FHI on cheese consumption. I'll talk a little bit about some potential mechanistic reasons for this, and then some potential applications of these results as well. And so just to highlight here that Food for Health Ireland, so a lot of the research that I'm going to talk about today and some of those research results are funded by Food for Health Ireland, which is a technology centre based in UCD, supported by Enterprise Ireland. And if anyone is interested in hearing or reading more about that, you can go to the FHI3 website and hear more about it, read more about it there. So moving on then to reductionist approaches in food and health. And so for those of us who are of a certain age, you may recognize this little picture down here in the bottom right. I'm looking at some of the people on the call here. So some of you probably may not have remembered this at all, but some of you may. So this was a sort of famous ad, and the sort of tune went, them bones need calcium. And so this is, I suppose, a really good example actually of foods that are being recognized, or food groups that are recognized for their individual nutrients. So for example, calcium and bone health. And it is an example of this reductionist approach to nutrition and diet and health, where there is a focus on a link between one nutrient and one health outcome. So in this case, calcium and bone health. And this figure here from Hoffman in 2003, just sort of is a diagram that just sort of shows those differences. So you can see here within the diagram, we can study at different levels of diet. We can study the food constituents, then we can study overall food items, and we can study food groups. So for example, dietary fiber in an apple, the food item itself is the apple, or as part of a food group, it's the fruit. And then if we consider the health aspects, we can look at biological markers. So for example, the lipid profile, we can look at components. So for example, coronary arteries, or we can look at systems health, so cardiovascular disease. And you can see by these solid lines here that they're very much the most studied relationships. So the links between the food constituents and those biological markers are very much the most studied relationships. Whereas if we look up here, those big links between diet and health are the least studied. And it's supposed that, the more of these sort of solid lines low down, or these tiny events that we study, they can help to explain the big ones. But like I said, that is this reductionist approach. And what it doesn't necessarily account for is some of those links between some of those food constituents, which is becoming more and more, I suppose, more and more studied more recently, and it's known as the food matrix effect. So if we consider food matrix effects, then I suppose that's really the concept of it, is these interactions between the individual nutrients themselves, but also the foods and the structures of those foods in which they are present and how they interact together. And so this diagram from Aguilera in 2019, again, is a really nice overview of that concept. So just to talk you through this, if we look here at the food itself, we can see that at this food, the nutrients here are represented by the black dots, and they're present within this food matrix, which is then present within this food microstructure. And we can see that that particular matrix and the microstructure can affect the digestion and the bioaccessibility of those nutrients. And it can also affect the bioavailability and the absorption of the nutrients as well. We can see that the food matrix is scale sensitive, and then also that it's compound specific as well. So when we talk about food matrix effects, really what we mean is this overall interaction of these nutrients within a food, how they interact with that structure and the rest of that matrix, and how it impacts digestion and absorption. And so if we think back then to the previous slide, if we compare foods on a single nutrient alone, so dairy foods based solely on their calcium content, we're losing some of the resolution of that information, how that nutrient interacts with the structure and with the other nutrients that lead or result in that health effect. So I suppose just a quick overview of reductionist approaches and food matrix effects that then bring us into some of the more recent evidence for dairy and cheese consumption and some of those health effects that we mentioned at the outset. So when we start then to look at the links between diet and health, meta-analyses really are at the moment to provide us with some of the best evidence of those links between diet and health. And there are many new meta-analyses in this area that pop up, new ones pop up every year as there become more and more studies that can be incorporated into them. So the one that I'm presenting here is from Jakobson et al. In 2021, so last year, that was published in Scientific Reports. And this is a nice meta-analysis because it looks at the effects of a number of different dairy products on coronary heart disease and ischemic stroke risk. And so we can see, I'm just going to go through this really, really briefly. I won't bore you too much with it. But you can see that they've looked, first of all, at milk overall in its kind of entirety, and they haven't seen a significant association between milk consumption. But then when they divide it into low-fat milk and high-fat milk, they can start to pull apart potential differences that might be there. And actually, in this particular meta-analysis, they did find a significant association between risk of coronary heart disease and high-fat milk consumption, which they wouldn't have seen if they had just focused on milk as a product rather than looking in more detail at different types of products. Then if we move on to cheese, which is I suppose it's a particular interest here in UCD, and we have a number of studies on it that we want to really focus on. But just to show you here then, if we look at, again, another dairy product, cheese, if we look at the effect, first of all, on coronary heart disease, we can see for coronary heart disease, for overall, if you can see that here, overall cheese consumption, and then they've divided it into low-fat cheese as well. And we can see that there were neutral effects for coronary heart disease, reduced risks for stroke, and differences between men and women as well. So I suppose what I really want to highlight here is the fact that when we collect this kind of dietary information, food consumption data can be unreliable, and it's not always collected in such a way that allows these individual foods to be examined like this. So quite often dairy foods are grouped together as a single food group, such as dairy, rather than allowing us to be able to look at the different types of cheese, for example, here, or in the previous example, the different levels of fat content of the milk. And as we've seen, those different foods have very, very different effects. The matrices are very different. And because of this, they can have different outcomes on health. So this is just another way, I suppose, to show that dairy foods are not all the same. Like we mentioned, the dairy shelf, if you like, often consists of milk, cheese and yogurt. But even this is really, really simplistic. So there are different types of milk. If we think about cheeses, they all have very different matrices. Some of them are, hard cheeses. We have soft cheeses. So, the sort of content of the protein can be in a different form, and the same for yogurt as well. And then, of course, the proteins that are in there, the peptides, the fat content are all very different, and the sugars that are present as well. And yet, we do often put them on the same shelf when it comes to dietary guidelines and dietary recommendations. And so for those purposes, they're quite often considered equal when we can see that actually they can all react very differently. Again, this is another overview just to show you in a little bit more detail the differences between some of those different dairy foods that we just showed. So it's a very simple table from Thorning in 2017, and really it's just to try and get across those differences in structure. So what we've done here is we've just taken an average cheese and two different types of average milks, with skimmed and a whole milk, an average yogurt, a cream and a butter, and divided them into the different contents for calcium, for phosphorus, the milk fat globule membrane content, or the sphingolipid content. And you can see that that's really, really different. So really, really high content in cream, but virtually non-existent in butter. And again, that's because of those the processing conditions. We can see that the protein types are very, very different. So cheese, most of the protein in cheese, depending on the particular cheese, the vast majority of them is a casein based protein content, whereas for milk and for yogurt it's going to be a mixture of both whey and casein. If we look at the fat structure, then they're all very different as well, and the protein networks, as we mentioned, are very different as well. So the protein network in milk, for example, is going to be liquid, whereas the protein networks in some cheeses may be solid or even viscoelastic, depending on the type of cheese. So they're all vary hugely in terms of the structure, and this can result in very different health effects. And there's quite a lot of evidence for beneficial health effects from cheese, and surprisingly, some beneficial health effects for cheese on blood lipid parameters. And so I just want to show you a figure here, which is from a study that we published back in 2018. And in this study, we gave people dairy fat in 3 different forms. So in group A, which you can see here in the grey, those people were given their fat all in the form of cheese for 6 weeks. Group B were given the same amount of fat, but they consumed it half in the form of a reduced fat cheese, and they also had butter to make up the same amount. And then in group C here, which you can see in the lighter grey, these guys all had a broken down form, if you like. So they had butter, they had a calcium caseinate powder, and they had a calcium supplement as well. So they had overall the same constituents of cheese, but it was in a broken down form. And really what this figure shows is the importance of that matrix, because we can see that even though these guys had the exact same content from a macronutrient perspective, we see very, very different results in terms of their blood lipid profiles after 6 weeks. So there was 127 people that took part in this study. There were sort of over 50 healthy, and you can see that we saw a reduction in their total cholesterol here, but it was very much in a stepwise effect. So we saw the greatest reduction in total cholesterol in the guys that had their fat in the form of cheese, followed by the guys who had half of their fat in the form of cheese and half in the form of butter. And then we can see the butter one here. So very much a stepwise reaction or relationship. And we can see here, if we look at the HDL results, we don't see a huge difference in the HDL. So we can see here it's very much driven by reductions in their LDL cholesterol. And that greatest reduction was observed when all of that fat was consumed in the matrix of cheese. So really showing that there is something quite special about the matrix of cheese. And this was a high normal fat, can't think of the word, Irish cheddar cheese, excuse me. So I suppose, so that was, while it was really interesting, and it certainly, was actually quite in line with some of the studies now that we're starting to see from some of the other countries as well. What we are now interested in is looking into this in a little bit more detail. So, while those reductions in LDL cholesterol are interesting, we know that the particle size of the LDL cholesterol may actually be even more indicative of potential cardiovascular disease risk than LDL cholesterol alone. And just to sort of illustrate that, this figure shows 2 hypothetical people who have the same level of blood cholesterol, LDL cholesterol concentration, but you can see that cholesterol is held in very different particle sizes. And so this large LDL, these larger particles, are associated with a much lower risk than these smaller particles, which are known to be much more atherogenic, and they're associated with a much greater risk of CVD risk, even though the overall LDL is the same in both of those figures. So as part of this, one of the PhD students on the project has looked a little bit further into the particle sizes of these, and I won't, in the interest of time, go into these in a huge amount of detail, but just to show you that within those same groups again, so group A were the guys who had the cheese, who consumed the cheese for 6 weeks. Group B were the guys who had half their fat in the form of cheese and half their fat in the form of butter. And then group C were the butter group. And you can see here, so these figures, and I'm going to show you a lot of these, so I'll just run through and explain what they are. These figures show the pre and the post values for these particle sizes. So this is for the total HDL particle size. So you can see it here for the total group. And then she's also looked at it in group A, group B, and group C to see if there is a food matrix effect within these as well. And she's also looked at the different particle sizes for the HDL. So she's looked at the large, the medium, and the small particle sizes there. And she's done the same for the VLDL. So these are the really atherogenic ones. And I suppose just to really run through very briefly here, that you can see that actually we do see that reduction in the small here, whereas we see sort of an overall, I suppose, a change, if you like, from the least, from the most atherogenic profiles towards a lower atherogenic profile. And just to run through that, I suppose, really, really briefly. So what she's done here is she has plotted the correlations between the change in the VLDL, so those really small particle sizes, against the change in small. And what you can see is we see a really, really strong correlation here. So this is really very indicative of any reductions that are seen in that total VLDL profile being driven by reductions in the small. And we can see, so this is for the total population here, and then we can see that here for group A, for group B, and group C. So you can see that it's quite similar for each of those diets for the VLDL particle sizes. When we look at the LDL particles, it's not as clear cut, so that relationship is not as strong, and that work is under review at the moment. But just some really interesting findings there for, I suppose, to understand a little bit more about what's happening with those kinds of studies. So then to understand some differences in response. So as you can see, not everyone in those groups had the exact same response. So overall, if we think back, and I'll just go back to this figure here. So just to show you that, this shows us the overall mean reduction that we see in each of those different groups. But that doesn't show us the differences that we see within those groups as well. So what this diagram is showing, and this is from Aileen O'Connor's work, is a postdoc in our group, and she's been looking more at some of the individual differences in response. And what you can see here in this figure is what she's done here is she's plotted the overall distribution of the individual differences in response for total cholesterol in this. So you can see that while for most people there was a reduction in the total cholesterol, and you can see them here that they're grouped into tertile 1, we do see that that there are some people who did not have as strong of a reduction in the total cholesterol, and then actually we see here in tertile 3 that some people did have an increase in their total cholesterol as well, despite the fact that overall there was a mean reduction. So we do see some individual differences within the overall response. And so Aileen's work is very much focused on trying to understand what potentially might be influencing some of those individual differences in response that we see. So just to bring you back again to groups A, group B, and group C, and remind you that group A were the guys who had all of their fat in the form of cheese. Group B had 50% of their fat in the form of cheese and 50% in the form of butter. And then group C received all of their fat in this broken down form. So they had butter, they had a calcium caseinate powder, and they had a calcium supplement. So overall, they had the same macronutrient content, but it was in a very much different food matrix. And so what we can see is that within group A here, so this is the cheese group, we can see that there was very much, so we've got tertiles here. These are the tertiles of change. So tertiles 1, tertiles 2, and tertiles 3 relate back to these tertiles of overall change. And so we can see that within group A, most of those people that were in group A were in tertile 1. So in other words, most of them were people who had a reduction in their total cholesterol. Some people, however, did end up in tertile 2. So there was a less, I suppose, strong reduction. And then some of those people were in tertile 3. So some of those people that were on that cheese study did experience an increase in their total cholesterol. But we certainly see a food matrix effect here, where if we look at group C, even though the overall, if you remember back, the overall mean value for total cholesterol was a reduction, we do see that it's very different. So we see that most of the people were actually in group C, most of those people fell into tertile 3, so that most of them had a small increase to some extent in their total cholesterol compared to group A. So we very much see that food matrix effect, and we can see that there's very, very big differences there. So the distribution in the participants across the tertiles of total cholesterol is very different based on the food matrix. So what this is showing us is that there is definitely a food matrix effect, but it doesn't fully explain some of those differences in the individual responses. And so to look into that a little bit further then, Aileen did some work to look at the baseline characteristics. And what you can see here on the left-hand side is these differences in the baseline serum cholesterol between those tertiles. So she's just shown here the extremes of response, which is tertile 1 and tertile 3. So you can see here tertile 1 is in yellow. So those are the people who had the greatest reduction, or we also call them responders. So the greatest reduction in their total cholesterol compared to tertile 3. And we do see differences. So there was a difference in their baseline serum cholesterol, which possibly isn't that overly surprising, so that the people who had the greatest cholesterol starting out perhaps did not experience as much of a decrease compared to some of those other people. But again, it does help, I suppose, in our understanding of the people who will respond the best. And it is more of a move towards personalized nutrition and understanding more about baseline characteristics and how those people will respond to a food intervention. So you can see here, this one is for total cholesterol, and this one is for the LDL cholesterol on the right-hand side. And again, very much the same kinds of things that were important in both of those. So the baseline levels of total cholesterol and HDL, and also the starting levels of triacylglycerides were important as well. So with all of that then, we can see that, it is clear that differences in those food matrix very much have an influence on health outcomes. And this figure is from a recent overview of that cheese matrix effect, just to go through, I suppose, how the differences in the milk composition, milk pre-treatment, manufacturing processes, all of these things can influence food structure. And we know then that that food structure can also have an effect on how those nutrients are digested and absorbed. And that can also help to inform us then on food processing, food oral processing, and food preparation as well, and how those differences. So coming back to that link between diet and health, what we want to try and do now is to understand a little bit more about how those preparation processes, first of all, the food preparation and food processes themselves, and then also the food process before consumption can impact these links between diet and health as well. And so this figure is from another paper that's under review at the moment. This is from a small intervention study. So it was a really highly controlled crossover trial where, in conjunction with Chagask, we actually produced high and low calcium cheeses. And so what you can see here, we had 7 people in total who took part in this intervention study, and each of them took part in 3 different crossovers, if you like, where they had 2 weeks of a high calcium cheese, 2 weeks of a reduced calcium cheese, and then 2 weeks of a reduced calcium cheese plus a supplement that brought them up to that same level as the high calcium cheese diet. And what you can see here on the right-hand side, so this is the post-intervention fasting LDL cholesterol levels following that high calcium cheese. So this is the pre and the post. This is the high calcium cheese here. It seems to have got cut off slightly. This is the reduced calcium cheese here in the middle. And then this last one is the reduced calcium cheese plus the supplement. And so what we can see here is that the post-intervention levels, the fasting LDL cholesterol levels post-intervention are significantly lower after the high calcium cheese compared to the reduced calcium cheese and compared to the reduced calcium cheese plus the supplement. So again, what this is telling us, or at least suggesting to us, is that calcium content within the matrix of cheese is playing a key role there in some of those differences that we are seeing. And so, can we start to use that information in perhaps, naturally modifying the calcium content as we come to processing cheeses? Is it potentially a means by which to modify cheeses to, improve some of those potential health benefits as well? And then I suppose another quick, just realised I am coming up close to the time and I'm sure you're all down to get your lunch, but just really quickly then to show another quick study that's ongoing at the moment. Again, as I mentioned there in that last slide, we're really interested in the links between diet and health, and what are the, I suppose, what are the different methods or processing methods or preparation methods that might be influencing some of those potential links in cheese. And so one of these is whether or not that matrix and the integrity of that matrix, how important is it? And so, if we look at any of the large dietary intervention or any of the large dietary surveys, we'll know that, most of us, we tend to consume our cheese having been melted or cooked, whether on a toasty or on pizza and so on. And so it's to try and understand, what does that impact of melting have on some of those longer term effects? So some of those markers like LDL and HDL that we saw. And so that study is ongoing at the moment, and we hope to be able to share some of those results with you soon. So there are a huge number of people involved in all of these different studies. I'm just going to pop them up here because I realise we are coming a little bit close to the time for questions. So I'll just leave this slide here and say thank you to all of these people who've been involved in these studies, and thank you to you guys for listening as well. We're delighted to take any questions that anyone might have on any of that.